Hey guys, I just wanted to go over a scenario that you might run into, especially when you're working the delta math. And if you were in class yesterday, we were learning on the video to turn an exponential into a log to solve it. And today you're going to be working on a delta math and you might miss a problem and you might look at a solution and it might go about solving it differently than what we've learned. And I just wanted to go over the two scenarios and see what's going on. Um, and then you can either just decide to do it the way that I've been teaching you, which is my preferred method, or you can use the way that Delta Math does it, which is totally fine. There's a lot of teachers that use it that way. When you become a master of math, then you can do it any way you want. And it doesn't matter because it's just using a property. So I'm just going to go over this problem right here. It says 16 equals 3 times the exponential base 4 raised to the 5x. So the first thing I'm going to do is I'm going to go over here and I'm going to show you the way that I would approach this one. And I'm just going to divide. Remember, when you solve an exponential, you have to get the base of the exponential, which is 4, and the input, which is the exponent by itself, which I have just done by dividing by 3. Okay. Now what I'm going to do is I'm going to convert this into a log so I can solve it. We talked about that. So this is a log with the same base as the exponential. The input of the log is the output of the exponential, and the exponential is outputting 16/3. And then the output of the log is the input of the exponential, which is always the power or the exponent. Okay, so quick conversion. And now I'm ready to solve for x, and I'm going to divide everything by 5. Okay. And so now what I'm going to do is I'm just going to put this in my calculator. Maybe I want a 3 decimal point. Let's see what this asks for. It says round to the nearest tenth. Okay, so we'll round to the nearest tenth. Okay, so I'm going to go to my calculator and I'm going to put in, clear out my history. I'm going to go to math and I'm going to go to my log base. I suggest that when you do these, that you split them up into pieces on your calculator. So I'm just going to do the log base 4 of 16 divided by 3, and I'm going to hit enter. And then that's not quite my answer because that all needs to be divided by 4. So when you hit the division bar, your calculator is going to put this ANS, which is the answer previous with all the decimal points. And I don't have to retype it myself. And I'm going to divide by 5, and I'm going to hit enter. And this is my answer. So it's 0.24. What else do I have on there? And then I'll round it. 0.2415. So I want to round, I think it said to the nearest tenth. So it's going to be 0.2. Okay, now let me show you what your book does. Same first step because you can't escape that. You've got to divide by 3 and get the exponential by itself. But it's going to use, instead of the inverse, which we always solve every equation by the inverse, right? We square root a square. We use the inverse to solve, but this delta math, and sometimes a lot of times your book is going to use a property that we learned on Thursday, Friday. Remember, we learned the product property of logs, the quotient property where you can subtract them or divide them, and the power property where you can bring the power down. That's the one they're going to use. And what they're going to do is a little trick. They're going to put log, and they're usually going to use natural log or the log base 10. Kind of just depends on what the author wants to do. And the reason they're doing that is because your calculator has 2 quick buttons. It has log base 10 and the natural log on it. And I'd say probably 5 years ago, maybe 6 years ago, they updated these calculators so that now I can go to math and put log base 4 in. But before that, they didn't. Like back when I went into high school, they had natural log and log base 10. Those were the only 2 that you could put into your calculator. So I couldn't get a decimal answer by putting in log base 4 of 16 over 3. So this was a workaround your calculator by using this property. And so what this property does is allows me to use log base 10. which is a quick button on my calculator, and I can bring this power down. Now that this log base 10 is in front of this exponential, I can bring the 5x down, and that takes care of my power being, or my variable being a power. And now I can go ahead and I can solve this. So I'm going to take log of 16 over 3 base 10, and I'm just going to divide by 5 log of 4. So I'm going to take the 5 and the log of 4. So this is 5 times the log of 4. Okay, and then I get x by itself, and now I'm ready to put my calculator. I'm going to come over to my calculator, and I'm going to put in log of 16 over 3. I always accidentally put parentheses when I don't need them. And then I'm going to hit enter. And now what I want to do is I'm going to divide it by 5 log of 4. So I'm going to hit divide by, bring the previous 5 log of 4. And I'm going to hit enter. Well, and see, your calculator is really crazy. This is why it's sometimes can be hard to put this in. So I'm going to do 16 divided by 3 again, and I'm going to hit enter. That's the log base 10. And now I'm going to need parentheses. Oops. Now I'm going to hit divided by. Dang it. Divided by. There you go. Answer. And I'm going to have parentheses around this 5 log of 4. And notice I get the same answer that I did before. But notice how that's kind of really hard to put in my calculator. Notice the last time I didn't use parentheses after I divided. I just put in 5 log of 4. Well, what my calculator did is it took the previous answer, it divided it by 5, and then multiplied it by the log of 4. That's why I got a different answer. So I'm going to put in my 4 point. I just wanted to prove you're going to get the same exact answer. It doesn't matter. Okay. A little trickier to put it in this way. So my x is 0.2. Okay. Now, look at all the work that I had to do on this right side using the property of powers. That's what's going to happen when you use that option versus the quick inverse over here that we learned, getting the same exact decimal and the exact same answer. However, Delta Math isn't going to show you that way. But I also wanted to show you the ability to be able to convert your answer into whatever answer you would like. So remember, I'm going to rewind a little bit. So I'm going to take this problem back to when we were right here. There is a change of base. A change of base means I can take any log and change it into whatever base I want it to be. So how do I do that? I can take the log base 4 of 16 over 3 and convert it into a log base 10 by taking the log that I want to convert it into, that base, so this is base 10, and creating a division problem where the input of the top log is the input of the log that I'm converting from, and the base is the bottom input. And there we go. This is my answer. Okay, so when I divide this by 5, right, this is the same as multiplying by a fifth. I get the same answer over here. Okay, so that's like a little bit of a workaround if you wanted it, maybe your answer in your book wasn't log base 4. So I just want to go over a couple change of log scenarios because this is what this lesson's kind of about. So let's say I have log base 2 of, let's do 12. Okay, so let's go to my calculator. I'm going to do a quick split screen, and I'm going to put log base 2 of 12 in. And I'm going to get this 3.584962501. Okay, I can convert this into any log. I can do log base 10. So log base 10 of 12 divided by log base 10 of 2. Remember, the base always goes in the base. Look, I can take log of 12, right? And I can divide that by log of 2. And I'm going to get the exact same answer. Notice on my calculator, I get 3.584962501. I can change this into any log. I can do natural log of 12 divided by natural log of 2. Natural log of 12 divided by natural log of 2. This is called change of base formula. Okay, and I get the exact same answer. Okay, I can convert whatever log I want into another log by just saying, hey, I want to convert this into log base. Let's do 0.5. I don't know why you'd want to do that, but I'm just showing the point that it doesn't matter. And you could do log of base 0.5 divided by 2. And I could come over here to my calculator and I would have to select this one. I go log of 0.5 of 12 divided by, and I'll have to go back. This is the one that should have a quick button on in your calculator. And 0.5 of 2. Boom, same answer. So I just wanted to let you know that is why it's a little bit different, and not to be able to know where it's coming from. And so if I show the solution here, you'll see. And they even wrote this as a decimal. Boo, never write 16/3 as a decimal. Wait until why they would take the log and not put 16/3 and then put an estimate. I have no clue. I don't like that. But anyways, they evaluated that log and then they just kept evaluating the logs until they got the decimal of 0.2. Okay. So anyways, I just wanted you to go over that. I wanted to go over that with you so it did not confuse you. Remember today I have tutoring from 12 to 2. See ya.